All right, good morning. Welcome back to my stream. Let's switch over. There we go. And then take a look at where we left off. So where we left off was creating these UpValue local references to closure variables. I don't know if I could say it more awkwardly than that, but that's what we were doing. And we've gotten it working. Unfortunately, the way this chapter seems to be constructed is we don't get a working something partway through, and then we can keep going and try something else. Like previous chapter, we got if statements working. Hi, Clert. How are you? Thank you for joining. So, like I said in previous chapters, we can get if statements working and try them out, and get while loops working and try them out, and then for loops and so on. And this seems to be all one giant wodge of work, right? Because we got a point where we're actually compiling, right? But the VM doesn't use anything that we're doing. So we can't actually try it out to see if it's working. All we can do is try it to see if it compiles correctly. And this is the first part of the code where we can actually see, yeah, this is what he says it should look like, and this is what we are getting, and they match exactly right down to the byte code number. And so we know we're on the right track, but we can't, there's nothing we can try, right? I can't run this won't work, for example. And that's what we tried here, is we tried running it, and it didn't print. We didn't call outer, but I bet if we could try calling outer, it wouldn't work. Let's try it. So let's take, I did. I added the call to outer. Okay, I forgot that I did that. So where is the call? So here's where we're executing it, right? We start with this line here. We say there's a closure, there's an outer, and we try calling outer. It gets a constant 1, 2. It sees this closure, and looks like it's just pushing the function on and then returning. So somehow we have middle on the stack, and then we pop it off the stack, and then we're done. So it's not actually doing anything. Outer is calling, has a closure of middle, but it's not doing anything with it. Oh, that's true. That's what it's doing here. Nothing's calling inner. So even though we're calling outer, it doesn't do anything. Okay, so it doesn't matter. What if we added calls to all that? If I said middle here, and then said inner here, what would happen? Would it just panic or crash or something? It doesn't actually call middle. So nothing changed. Here's middle. Here's the call. You have a get local 3, which must be the middle function, right? And then the call, opcode call. Line 4, bytecode 14, we never get to. So I don't know what's happening, and obviously something's going wrong because we don't have all of the VM. Kurt says, are you crafting an interpreter with Rust? Yeah, so I'm taking this, I already ported the Java version of this thing. If we look over here, locks AST, we have the Java version ported to Rust, and that works pretty well. So that should actually run our sample. If I say cargo run locks bytecode sample, let's see what happens. Compiles, builds, and it prints out 10. Right? 1 plus 2 plus 3 plus 4 is 10. So that works. And now we're working on the C version of it that I'm porting to Rust. Ooh, that's not good to have that. Okay, so it compiles, it builds, it's up on the GitHub. Let's take a look at UpValue objects, because I got a feeling this is going to get even more awkward than it was last stream. Each op closure instruction is now followed by a series of bytes that specify the op values the obj closure should own. What happens when we hit the obj closure opcode? Oh, we do something with it. We push the closure on there, but we don't do anything with those extra values. PM user, hi, good to see you. Before we process those operands, right, we need a runtime representation for UpValues. We know UpValues must manage closed over variables that no longer live on the stack, which implies some amount of dynamic allocation. All right, so let's see what our stack looks like right now is just a vec of values. If we're going to move things off of the stack, that means we have to be able to clone the value, which we already can, right? I've implemented clone for value here. So that part's done at least. But I don't know, maybe this should be an RC. And that way we don't have to clone the value, we just clone the reference count and then pull it off the stack that way. I don't know what that would entail, because there's a lot of work that we do with the stack. Like for example, I was just looking down here at this line. We have an RC function for the closure, and inside the closure we have an RC, or inside the value for the closure we have an RC. And so what I'm proposing is doing another RC new here, right? And it would require it all throughout the rest of the code to do that. So maybe cloning off the stack would be the best option here. The only issue with that is, what if we need to refer to the value on the stack? Well, let's keep reading. We know the easiest way that in our VM is, the easiest way to do that in our VM is by building on the object system we already have. That way, when we implement a garbage collector in the next chapter, the GC can manage memory for UpValues too. Thus, our runtime UpValue structure is an obj update. Is an obj UpValue with the typical obj header field, and then a pointer to the location. Following that is location field that points to the closed over variable. Note that this is a pointer to a value, not a value itself. It's a reference, there you go, to a variable, not a value. This is important because it means that when we assign to the variable the UpValue captures, we're assigning to the actual variable, not a copy. Right, so I don't want to clone off the stack then. Right, I want to refer directly to the value that's on the stack. This should print assigned, even though the closure assigns to X and the surrounding function accesses it. Right, so this is, we call inner, we set X to assigned, and then we print X. So let's see what this does. I'm going to undo whatever I did here. Assign locks. So let's do that. Cargo run. And I don't think it's going to work again because it's not, yeah, we can't call closures yet. So I think what it means is that we need to be able to refer to variables on the stack from this UpValue, obj UpValue thing, which means I think we have to do this refactoring of making this an RC. And that's going to break a lot of stuff, isn't it? What is it going to break? Let's go through that exercise now. Yeah, so I was saying we have to have an RC here. And what's next? Oh, how do you do this? I think with the deref. And where does deref come from? Standard something. It comes from standard ops. Okay. Oh, which reminds me, we're using standard ops for adding and subtracting variables. I wonder, values, sorry, I wonder how that's going to change things. Yeah, so all these self-stack pushes are going to have to be RC'd. Should we? Because we have a pop. We have a self-stack pop unwrap, which gives back a value, which now has to give back an RC value. Should we make a fn push of mod self value and just say self stack push RC new value? Will that be a useful helper function? Yeah. And then globals insert. So the globals is just a string value thing. Yeah. So should this be a string RC value, or should this be... Should the globals themselves contain a new RC? So we don't want to, in the globals, we don't want to refer back to the stack, right? We're popping this off the stack here, and the P is going to be an RC value, right? I just changed that. If we clone it here, can I do that? Nope. Expected enum value, what did we get? Oh, I'm looking at the wrong. Oh, it just says mismatched types. Oh, expected enum value found ampersand value. Oh, okay. So I do it the other way around. Yeah, okay. And then this is push v.clone. Oh, we want to be able to, yeah, we can just push it directly. Right? Nope. I found a reference. Yeah, this V is a reference, so should I make it like that? And that'll change this, and I just have to ampersand that. Now, hopefully that won't cause us issues with the oh, right, and then this just can change to this. Right, okay. This is gonna take a little while, isn't it? Self stack is equal to self peak. Oh, peak, we need to make sure that it returns reference to an RC. Okay. And now this one, expected a value. Oh, we need, yeah, okay. Deref? Can I deref it like that? Nope. Because this expected value now found value. And I can't do that, right? That's gonna blow up. No, that worked. Okay, well, I mean, it got past one stage of the compilation. Self-read constant. What does read constant return? Read constant returns a value. And so, do that. Okay, that seems to work. Oh, all of these need to be ampersanded too, right? Okay. Oh yeah, okay. So here's where we're going to run into issues, right? Because this value is an RC. Can I do a deref here and make that a value, and then do this, and then do this? Nope. Can't apply unary operator. Mismatched types. Oh, that's the second one. So why can't we apply unary operator? Oh, to ampersand value. Can I do that? Okay, it's not complaining. Oh, right, duh. Okay. Which means now I have to fix all of the pushes. Or I can do this. I don't know if I can do that because that's going to extract it out. Change all these back. Oops. Okay. All right, so here we're peaking. This expression has RC value. Okay, so we can do another deref here. That seems to work. If I do a deref off of every peak, maybe that's what peak should do. Let's find out though. What is this? When we call the call, okay, function. Function is expecting. Where's the trait? Oh, the trait is not. What's the trait? I forgot what the trait is called. It's din something. Display function. That's it? Wait a minute. Oops, value. Native func. No? Function. Oh, yeah, sorry. We're in the native section. I was looking at the wrong thing. So this is just, this is expecting a reference to an array of values, and the stack is now is RC values. So can we do that? Without blowing things up too badly, and do it in the impl. Okay, and then this can be this, maybe. Okay, so now all of this blows up. So here's SelfPop Dref. That still blows up. Oh, and it's still finding that. Can I don't know if I can do that. Nope. Actually, maybe I can. Well, it hasn't complained yet. Let's see what the borrow checker says. Okay, and this was, how did I fix the other one? Just with a deref? Yeah, okay, so now we have issues, right? Now the borrow checker is saying, okay, we're moving stuff, and that's going to be in every location. Move occurs. Temporary value dropped while borrowed. Yeah, okay, so we can't do it this way. Can we clone our way out of trouble here? We're already cloning this. What does peak return? Just a value? Oh, it returns an RC value. Okay. And then we're copying it over to here. Can I clone this? Nope. Oh, Can I move this here? Because we don't need that outside, right? No. It's still okay, wait, mutable borrow. Oh yeah, so we do need it outside because we need to get okay. So self peak returns an RC value, right? If we look at that and clone it, we get our own well, so if I do this, expected enum value found struct RC. So can I go deref clone here? No, because I'm doing an immutable borrow. Okay. So let q equals p.deref. Sometimes you have to split things up, so I'm not sure if this is one of those cases or I'm just going off the deep end here. Okay. So far so good. And then so maybe we need to do the same thing here. Let q. So I did a self pop, and pop returns an RC, so I can clone that. And now value is a clone. And if I can say, can I do this? Dref. Clone. Nope. Still not good. Value can't be dereferenced. Oh, okay. And then we have the same thing here. We're creating temporary values. So you do a SelfPop clone. Oops. SelfPop clone. And can I do an ADref clone? It's kind of annoying now that I have to do all these cloning stuff of the values. I think I was before anyway. Okay, and now we have two warnings. Oh, and this is a situation where it should not be allowed. So let's see if we can fix this. Self globals get. Right, this is where we're trying to make a copy. Ooh, okay. Yeah, I want to destructure the V, and then I want to push it onto the stack, but I'm borrowing globals here immutably. And I don't think I can let u equals v.clone. Because I don't think that'll work getting it out of it, because self globals is still borrowed here. Oh, that did work. The warnings went away. Okay. So that's all I had to do was do it in 2 steps, and that way globals could get dropped before I called push. Interesting. All right, so now that we've done that refactoring, everything should still work, right? Let's build release, and then I have a for loop here. Let's make sure all of these things still run without panicking. Of course, this panicked because we haven't implemented the inner closure stuff yet. That's okay. This should still work, and that panicked. So we got to take a look at that. I broke something when I did the refactoring. And I think I'm going to change fib to not go so deep, because this takes forever. Okay. Because UpValues are objects, we've got all the usual object machinery. Okay, I'm not worried about this just yet. So everything else worked. Oh, make closure failed. Fib worked. Let's change fib so it doesn't take so long. Instead of fib 35, let's do fib 25. That should go faster. Okay, so let's take a look at line 89. Oh, because I'm doing, okay. That makes sense. Okay, I can live with that. I can live with all these right now because we don't have the UpValues yet. All right, so UpValue looks like we're trying to make it an object, which in our world is one of these things, right? So UpValue it would be something like that, and then UpValue just contains a value, a location, which is a value. So I think this is all that this is doing here, right? It just has a value, has a pointer, in our case an RC, to a value. And that could be pointing to the stack, or it could be pointing to the heap, right? Unfortunately, I think I made everything a lot slower now because I'm doing a lot of cloning that I wasn't doing before. Or the cloning I was doing before was hidden from me by the compiler. All right, so this we don't have to worry about because we get that from Rust. This we don't have to worry about because we get that from the enum. And this we don't have to worry about because Rust will handle that for us. Printing. Oh, right. So all of these things need to be handled. I guess we don't need to worry about partial ORed. Partial EQ. I wonder if we ever compare Rust values. I mean, UpValues, Rust values. But I could do the same thing here, right? And then here's debug for native func. Here's clone for value. Why is native func stuck in here? Let's put these together. Yeah, these should go together. And then we have clone. So cloning an up value is the same thing as cloning a function or a closure. Why do I call that F? I'm just mirroring the names here. Okay. And then display, and this is where we're getting here. And we never print them, so it shouldn't matter. And all they say is UpValue. Okay, I can do that. Does that work? Nope. Oh, because we don't have debug for UpValue. Okay, and warnings just because we're not using them. Right, okay, so that's that. I mean, but I don't know if this is the right approach for us, right? I'm just doing this because I'm following along with the C thing. UpValues in closures. When I first introduced UpValues, I said each closure has an array of them. We're finally worked our way back to implementing that. So they're saying in closure, which is over here. Oh yeah, captured variables go here. So we can replace this with UpValues, which is going to be a vec rc of UpValue. Which means we need value. And now we'll get even more warnings that we're not using it. Oh, missing UpValues, UpValues, vec new. Okay, yeah, now we're up to 4 warnings. Okay, different closures may have different numbers of UpValues, so we need a dynamic array. Right, so vec is a dynamic array already. Storing UpValue count in the closure is redundant because the object function that the object closure references also keeps that count. As usual, this weird code is to appease the garbage collector. The collector may need to know the object closure UpValue array size after the closure's corresponding object function has already been freed. All right, so our UpValue count is stored inside the vec, so we don't have to worry about that. When we create an object closure, we allocate an UpValue array of the proper size, which we determine at compile time and stored in the object function. Do I need to pre-initialize all these to null? I mean, you have to do it in C just to keep things clean, right? That way you'll get a segmentation fault if you try to access something, and you'll know you have a bug in your code. But with the vec, we can just index it using the square brackets. And if it's not initialized yet, then Rust will panic for us. So I think we're okay. We don't have to do this. Before creating the closure object itself, we allocate the array of UpValues. Right, that's this. So weird ceremony around memory is a careful dance to please the forthcoming garbage collection deities. Ensures the memory manager never sees uninitialized memory. So yeah, so I'm not going to actually do anything with the garbage collection, which means we skip a whole chapter of this book. We also skip the whole chapter on hash, although I think I skimmed it. All right, so this stores the UpValues in the closure, right there. And this frees them. We don't have to worry about that. We fill the UpValue array over in the interpreter when it creates a closure. This is where we walk through all the operands after op closure to see what kind of UpValue each slot captures. All right, so let's go over to the VM. Here's our closure code. Here's where we do a push of the new closure. So now we're going to go through each of the closures up values. Oh, so we need to know the closures up values, which means we need to know the functions up values, the count, to know how many to read. So I can actually store that right here. Let UpValue count equals this function dot arity UpValue count. Okay. Like that. It may be that this gets moved here, so I can't use it here, right? Help add semicolon. Yeah, so we can't use that, but what I can do is set let UpValue count equals here function UpValues. You get that way, and then just UpValue count here. And that way we can pull it out. Now we have another warning saying that we're not using UpValue count, but we're going to use it here for something, anything in 0 to UpValue count. Now we're going to read bytes. I guess we read them in as U8, but this should be a bool. Let index equals self read byte as a U8. If is local closure, which we just created, and now we need to modify. Oh, okay, so we don't need to do it here. We need to do it here. Right, we created the closure, and now we're going to modify it. Closure set up value of, or push up value. Capture up value frame slots plus index. Let captured equals self capture value. This might cause borrow issues. Frame slots plus index. Let's take a look at where we use slots elsewhere. Current frame slots is the slot offset plus index. Okay. Oh, so we do need this as usize. Let offset equals self current frame slots plus index and then capture value of offset. I'm doing it in 2 steps because I don't know if borrow is going to be complaining about doing the immutable borrow here followed by a immutable borrow, I guess, here. And then we'll have to figure out what capture value does. And then we're going to say closure push up value, because we're just pushing it on in the up value thing of captured. Else, we're going to say frame closure up values of index. I don't think we have that info, right? We have the function. I'm just going to close this out and then take a look at our frame. Our call frame looks like this. Yeah. So this function is now not a function, it's a closure. Right? So where do we use that? Not there, not there. Current frame, this should be closure. So let me refactor that as well, but let me do this first. So I think that's all we're doing is let captured equals self current frame function closure. and then we're going to grab it from the stack, right? So we're grabbing the chunk this way. I guess we need to do the same thing for UpValues. UpValue, I guess we can pass the index in here, and that way we can get it directly. And we can pass back an RC of value. Right? UpValue of offset, useSize. We get this function. It's a closure. And now C has an UpValue. So we say GetUpValue of offset. And now we're going to have to modify closure to return that. And we're also going to have to add push UpValue. So self current frame function. We don't need to do that anymore. We can just call self UpValue of index. And then closure push UpValue of captured. Right? And then we have to write push UpValue, and we have to write get UpValue. No UpValue. Is that it? And we can actually do this. Let captured equals this. This can come down here. This can come here, and this can just return this. Right? Okay. So given that, we have 5. Oh. Wasn't it like here? GetUpValue. We don't have GetUpValue yet, right? I knew that. We don't have CaptureValue, and we don't have pushUpValue. Okay, so in our closure code, we're going to have to add those pub fun push UpValue. RC value. And we just say self UpValues push value. Is that going to work? Is that going to blow up? RC clone value. Nope, still not good. Expected a reference. Oh, okay. What? Expected struct value found enum value. Oh, it's an UpValue. Right. I forgot. So what does it UpValue look like? It just has the location. Ah, okay. UpValue of location. I guess I should make a new for it, right? Value. Right, and I can just write a quick impl UpValue pub fun new value RC value. And return self. We do a self location value RC clone value. I guess, should I do it this way? I don't know which makes more sense to do it this way or this way. Oops, I got one extra thing here. No? Oh. There. And then this maybe goes here. RC new. There. And now we need GetUpValue, right? Okay, so that's pub fun GetUpValue, and should that return? That returns an RC value. Self offset useSize RC value, and it's just SelfUpValues of offset. And we let it panic if it fails. Oh. Not location. Or should I? Value like that. And then values. Pub fun value. Self. RC value. Self location. All right. So now we have an error here on CaptureUpValue and cannot cast as bool. Oh, what does readByte return? A U8. I can't convert a U8 to a bool, but I can do this. I thought I could. If self readByte equals 0, false, else true. What happened to this thing here? Okay, so now all we have is CaptureValue, and I think we're going to get to that. Let me quit out of this because I think I broke it. All right. Yeah, okay, good. And CaptureValue has to return the same thing as whatever UpValue returns. So what is UpValue? UpValue returns an RC value. Okay, so we'll do that. This code is the magic moment when a closure comes to life. We iterate over each UpValue the closure expects. For each one, we read a pair of operand bytes. If the UpValue closes over a local variable in the enclosing function, we let CaptureValue do the work, which we haven't written. Otherwise, we capture an UpValue from the surrounding function. An UpClosure instruction is emitted at the end of the function declaration. The moment we are executing that declaration, the current function is the surrounding one. Oh, okay. So that means the current function's closure is stored in the call frame at the top of the call stack. Okay, so to grab the UpValue from the enclosing function, we can read it right from the frame local variable, which caches a reference to that call frame. And I'm just using this current frame instead of using that frame local variable, current frame. Closing over a local variable is more interesting. Most of the work happens in a separate function, but first we calculate the argument to pass to it. We need to grab a pointer to the capture local slot in the surrounding function's stack window. Did you get all that? The captured local's slot in the surrounding function's stack window. That window begins at frame slots, which points to slot 0, adding index offsets to that local slot we want to capture. We pass that pointer here. This isn't doing very much, is it? Oh, okay, there we go. This seems a little silly. All it does is create a new UpValue that captures a given stack slot and returns it. Okay, so we can do that. Did we need a separate function for this? Well, no, not yet. But you know we're going to end up sticking more code in here. Okay, so we have UpValue. Let's write a function capture UpValue. Self. And what are we passing? We're passing in an RC, of the value. Oh, capture value, I called it. It should be capture UpValue. Okay. Oh, we're passing in just the offset. Okay, that's fine. And it should return RC value. Okay, so this actually does the create of the UpValue. So all we're actually doing is passing back from the stack, right? So I was just looking at comparing this. This UpValue is coming out of the constants from the function. No, but this is coming out of the stack position. Huh. Did I do this wrong? Am I thinking about this wrong? We need to capture the UpValue, from the current stack. This is getting the closure from the current stack and getting the UpValue from the closure. Okay. All right, so all we need to do is say let position is equal to self current frame function. And right, and I was going to change it to closure. And we're going to do this essentially. Oh no, we just need to get this the stack position from the offset. Self stack of offset. That's what we're looking for, dref. So is this it? It's just as simple as the other one. Expected RC value, but found, I don't want to, I want to clone the RC that's on there. Yeah. Expected RC value, found struct RC. Okay. But is that going to create a temporary that blows up? What's this? Oh, can I make this a reference? Or is that going to cause issues? RC clone. Okay, I have 3 warnings because we're not using UpValue count. Oh, we're not using UpValue count. Why not? 105. Oh, right, we no longer need that because I pulled it all out. And that means the semicolon can go away and we don't need to return it. Okay. Still 2 warnings. Oh, that's because we're not using UpValue. We're never constructing an UpValue and pushing an UpValue on the stack. So do we actually need that then? Okay, well, let's keep going and see. Maybe those get pushed on the stack, but I don't think so. First, let's wrap up what we're working on. Back in the interpreter code for handling op closure, we eventually finish iterating through the UpValue array and initialize each one. Right? When that completes, we have a new closure with an array full of UpValues pointing to variables. With that in hand, we can implement the instructions that work with those UpValues. Right, we commented these out or made them to-dos. So, for GetUpValue, we're going to make it do something, and then SetUpValue is going to be to-do. Okay, so we're going to say let slot equals self read byte as usize, because we're going to use it as an index, and we're going to say self push frame closure UpValue slot location. Self stack push, because we're going to grab an RC. Self current frame. Oh no. Oh no, no, no. We want to get the closures UpValue. Which is just this self UpValue thing, right? Yes. And that returns an RC. So RC clone of self UpValue of slot. Is that it? Two warnings, again, because we're not using the UpValue. The operand is the index into the current function's UpValue array, so we simply look up the corresponding UpValue and dereference its location pointer to read the value in that slot. Setting a variable is similar. So that's this guy here. Let slot is a self read byte as usize. And then we're going to set the up value at a specific slot. So now we need to be able to do that, which we don't have the capability of right now. If we look at closure, we can push an up value, but we can't set one at a specific slot. Pub fun modify self offset usize value RC value. It doesn't return anything. Self up values offset. Ooh, now that's mutable. That's going to be an issue, isn't it? Equal to RC clone value. So we want to say self. We have to get to the closure, which is done just like this. So maybe we call this GetUpValue. I'm hitting J. How do I make it bigger? Oh, Control K doesn't work. That's how. Okay, so this would be GetUpValue. All right, I'll have to fix that in a second. And then, actually, what I can do, resize -4. I can say resize +12. There we go. Okay, this GetUpValue and then SetUpValue would be this. And then value, RC value, doesn't return anything. We get this and we say modify offset value. And then we do here, we say self set up value slot. Oh, we have to peak, right? Let value is equal to self peak 0. Oh, I'm gonna have to do something, right? Clone it or deref it or deref clone. Oh, I don't want to. I don't want the actual value. I want the RC still, right? So I might be able to just get away with this. Let's find out. What's this issue? Expected up value. Oh. Oh, Why is this in RC then? I guess up value, new value. This is also get up value. Okay, set up value can take a reference. And then the bar checker is going to kill us. Cannot borrow is mutable. Help trait deref mute is required to modify through a dereference but is not implemented for RC closure. This is where I can put like a mut in here. Data moved. Oh, I don't want, okay, I don't want to, Can I do this? Nope. Had it help add up, oh, like this. Nope, can't do that. Expected RC found value. And I can't do this either, right? No. Nope. Yeah, and this is the data moved, and we don't want to move the data. We just want to, grab, If I do this, I can't use this because I can't borrow it as mutable, but we can do the ref cell trick, which means changing everything. Okay. Okay, so UpValues here, borrow, mute, push. UpValues dot borrow. Huh? Can I do that? I don't know if the syntax allows that for that. I'm not trying to borrow it as mutable anymore. Didn't I change that? Oh, I didn't. Okay. Okay. I guess this syntax works. It's a little awkward looking, right? But it's not complaining. Oh, this doesn't have to be mutable anymore because we have the interior mutability, and then we have the I'm going to remove it because it looks like we don't even need it. Here. We still need the UpValue itself, and maybe this needs to go in its own file. But let's get it working first. Okay. No errors, no warnings. This is a milestone. As long as all of the variables remain on the stack, we have working closures. Try this. Try this. Run this and it correctly prints outside. And look at that. It actually printed outside. I'm a little bothered by the fact that we have inner on the stack twice, and we have outside on the stack twice, and we have outer here. But the fact that it's working, and we didn't get any locks panics, that's a good cargo run make. This was the one that panicked before. Now it's printing local. Is that what it's supposed to print? Locks AST, target, release, locks AST, make, closure. It is supposed to print local. Okay, so that's working too. Interesting. Release. Let's see if the for loop gets us through. All right, so no panics. It says donut bagel. This prints value. Is that what it was supposed to print? I've forgotten. Devious. When you run this, it should print return from outer, create inner closure, and value, and it does. Okay. All right, so we actually got this whole section working, huh? We got UpValue objects in. It's a little awkward because of all the RCs and all the indirections and this local business, location business. But let's source, let's create an UpValue. Just to move this stuff in there. I know it's just two things, but we're not actually using UpValue as a value on the stack, but we are. What are we doing with it, right? Because it's in the VM. Okay. It's the compiler. Oh, as this thing here. Ooh, yeah, that's not good. I'm using this UpValue, and this is object UpValue. Did I just break what I did here? Let me put that back. Maybe I don't even want any of this. Oh no, the closure contains the UpValue. That's right. If I look here, this contains all the UpValues. And I'm guessing that when we get to closed UpValues, that's when it's going to get complicated. So in the compiler, I'm going to change this to UpValue data. So that I can actually have this UpValues. I don't know how I ended up with that in there. Okay. Use standard RC. Is that the only fancy thing in here? And then in main, UpValues, and then in value. Oh, we don't need it in value. We need it in closure. Use crate UpValues star. No, I broke something. Oh, here. This needs crate value. What else did I break? Didn't I? Oh, okay. Maybe this broke because it didn't compile. No, ambiguous name. Is it going to tell me where they are? I thought I modified the compiler so that there was only one. It says ambiguous name, but it's not telling me what the... Oh, here. Oh, did I leave it in values? I did. There. Okay, that's better. All right, so we've refactored that out. And the other thing I wanted to refactor was in the VM to change all of these functions to closures. Because that's what it is now. And I'm going to let the compiler tell me where all the mistakes are now. Closure, 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 closure. Okay. Good. And then the last thing I wanted to do was comment or delete. We have some code here that's commented out that we don't need. Yeah, in the precedence. We don't need any of this. And then there was one other section of commented out code that I don't remember which file it was in. I'm just scanning very quickly here. It's not in here. Is it in the VM? No? Is it in the, what else would it be in? Maybe in value? I remember seeing a chunk of commented out. Here it is, yeah. String interning. Right, we don't need this. Okay. So this is section 25.3, which is UpValue objects. Let's see what Clippy has to say. Ooh, Clippy has a whole bunch of things to say. This expression borrows a reference that's immediately dereferenced by the... Okay, so all of my little reference things we can pull out. 78. Okay, and then we can just... let's do this. Cargo. Can I do that? I can. Good. All right, so that's that one. 126. Help. You can reduce this to not self-byte. Okay. That's what I was trying to do before with the as, but it wasn't liking it, so. That works. We don't need a, oh, excellent. We don't need a clone on there. I was overly zealous with my cloning. This value is dropped without oh yeah, because we, okay. So will that work? Do I need to do the deref clone business here? All right, let's see if this builds. It does. Let's check in with Clippy again. Not quite. Okay, now he's suggesting doing it the other way. That's fine. I don't mind. Oops, I left a bracket there. Okay. Wait. Oh, yeah. Okay. And we're clean. Good. Pum. So I guess I still need the derefs. Where's my binary? Op. There. I guess I still need the deref clones on here. Yeah, because we found struct, and if I say just deref on its own, and it's going to say value moved. Oh, expected enum value and found ampersand. And the only way to get around that, I guess, you know what? Oh, I can't because I implemented the ops. Oh, I wonder if we can do that. Right, and now over in value, can I do this? Can I add for value? Oh, now you need a lifetime parameter. So you can't do that. Actually, I can just see this, right? Yeah. Okay. The output can still be a brand new value. Doesn't need to lifetime it. All right, so we can just stick the values here like this and this. And this. And div for value. Neg for value. Gonna neg my values. Oh, right. And then that's the thing, is the neg I deref cloned. Can I get away without that? Let's find out. Yes. Okay. Perfect. So all I did was say that these implementing the operators for the reference to a value. I guess Rust doesn't do that for you automatically, right? But it's saying here, so self is now a reference to a value, others a reference to a value. Is this cloning it here? Or should I be doing this to avoid cloning it? I don't know if that makes a difference. I don't know if that makes a difference. That would be good to know because it compiles both ways. And I don't know if it's if here, for example, it's doing an implicit clone of the object. I'm going to put them in just because it builds with it and it feels like it might be the right thing to do. Where's add? Here's add. Yeah. All right. Let's leave it like that. Okay. So that's 25.2, 25.3 UpValue objects. All right. One more time with Clippy because I did a bunch of changes there. Yeah. Clippy's happy with those changes. Git status, git add source, git commit -m section 25.2 UpValue objects. Okay. I'm going to call it here for today because I got to get going. But that means that the next stream, which hopefully will be tomorrow, we'll do closed UpValues. And is that the last section in this chapter? This one's, oh wow, this one's a long one. Yeah. And then there's a couple of challenges. And then after that, oh boy. Oh, garbage collection, which I will skim through garbage collection, but I'm not going to do anything because there's nothing for us to do in Rust. We don't have to worry about chains of ownership. And then we'll get to classes and instances. But I think what I'm going to do, yeah, tomorrow, or sorry, it might be tomorrow, hopefully tomorrow, but the next stream, we're going to do closed UpValues, is what it was called, I think. UpValue objects. I wish that the chapter thing would work. If we had the full width, the chapter would work. Yeah. We're in closures, and then we can see here, yeah, closed UpValues. That's what we'll get to tomorrow, is closed UpValues. And then here it is. And then I want to take a break from the interpreters stuff and get back to either roguelike coding or there's something new that I was taking a look at here. Let me throw it here. Is building your own text editor. This is written in C, and I think this would be fun to port to Rust also. It says the text editor is anti-res kilo with some changes, about 1,000 lines of C in single file with no dependencies. It would be nice to do this with full test-driven development and learning how to use cross-term, because I haven't done cross-term yet. And I'd like to learn how to use cross-term. So this would be fun. Next stream is definitely going to finish up closers, or we'll get as far as we can, but it shouldn't take more than a single stream for me. And then we'll take a look at building my own in text editor in C. The other thing was this that I wanted to do, writing an OS in Rust, but this wouldn't involve any porting. It would just be copy pasting essentially the code, which is like what we did for the roguelike. All right, that's the stream. Thank you everyone for watching, and I will see you in the next stream with closed UpValues. Take care.